Okay, so in this video, we're going to complete the notes that we ended up with in class the other day after the quiz. So I've done A and B already. So I'm going to do 2 A and B on the next page. So just to recap, we're doing limits as h goes to 0, which is a more formal way of taking a derivative. Okay, you have to be very, very precise in doing this. So all my notation that you see here is essential. So that means, notation like this right here. Let me just not color that out. All this notation right here is very critical to earning full points. Okay? So same thing here. You need to have this. This is not optional stuff. Okay, so let's do the next 2 on the next page. Okay, so similar to the one I just did that needed a common denominator, this one will need a common denominator also. So let me see if I can write this out. So what I'm going to do is I'm going to say the limit as h approaches 0 of. So it's 1 over, add the h. So I'm going to put this in parens and say x plus h, close parens, minus the original function, all over x plus h minus x. Okay, so in order to do this, you have to get a common denominator. So limit as h approaches 0, I'm going to multiply the right term, the right denominator, which is 3x, times the first fraction, in this way. So I'm going to put, so let me see how I want to do this. Yeah, I'm just going to do this. Now we're over, getting a common denominator, x plus h times 3x, and then minus 3x plus h. So what I did is I combined those two fractions in the numerator into one fraction. Then what you want to do is remember we're going to be canceling out the x's so that h can just reside right here next to the other denominator. Okay, so I pop my x in there, my h in there. Okay, let's distribute. So I'm going to say 3x minus, very carefully, minus 3x minus 3h. Make sure you understand that because that's a critical movement right there. Then I have h out front. I'm going to put a paren because I have these multiplied inside. Okay, so remember what I always say, whatever doesn't have an h attached to it should cancel. This cancels with this because they're opposite signs. Okay, this h now can cancel with this, and I'm left with a -3. So time to rewrite once again. So the limit as h goes to 0 of -3, and then I'm going to have 3 times x plus h times 3x. Okay, so what's that going to be when we actually take the limit? So plug in the 0 for the h, and you will get, this will now equal -3 over. So 3x times 3x is 3x squared. Okay, and we can reduce that, but for safety's sake, I'm going to leave it the way it is. So that's another example of a common denominator. Okay, b over here, 1b, also gave us that same example. Now we have to go and do one more step because, well, I guess they don't really ask us to do it in A and B, so we're not. They're not asking us to evaluate it. So let's go back and we'll do the other, which is a conjugate pair. So we have not done this yet with limits. So I'm just going to draw a box here, and then I'll start working on the other one. So this is all this problem. Okay, so I'm going to change color so it's really clear which is which. Okay, so here we go. Conjugate pair is going to be our treatment plan. So the limit as h goes to 0 of. So I'm going to have a radical 4. Instead of just having an x, I'm going to say x plus h, and then minus radical 4x all over x plus h minus x. Okay, so I'm going to get rid of those right away. Okay, these two can go. All right, now, what I know is I cannot go further until I get rid of the radicals, and that's because I want to have that h in the denominator cancel. So I'm going to put this in parens, and I'm going to create the conjugate pair, which is going to be same here. Okay, different operation, so make that a plus now. Same here. Oops. Okay, so then put that over itself. Okay. Oops, I keep hitting that, sorry. Okay, there we have it. Okay, now we have to multiply these out. Now, I'm not going to do the whole multiplication, so I'm going to show you one thing, and I'll show you this down here. What if you had a minus b times a plus b? So let's see what that does for us. Okay, so if, let's just say that this was a minus b, and this was a plus b. When we fold it, what will we get? So let's look down in our little square. And we would get a squared minus ba plus ba minus b squared. And do we see how the middle terms will cancel? So when we do this multiplication, or this foiling, we're going to get a squared minus b squared. Okay, so since we see that's the same pattern, when I foil that whole radical situation up there, look what I'm going to get. So when I foil a times a, the radicals drop away, and I get 4 times x plus h. I know the middle terms are going to drop out, so I'm not going to do that here because it's going to be too cumbersome. Then bring a subtraction down and multiply 4x times 4x under the radical, and you get minus 4x. Okay? And then your denominator, I have the h left over, and then I'm going to put a big paren, and I'm going to have radical, backtrack, radical x 4 x plus h plus radical 4x. Okay, so let me think about that for a second. Is that right? No. So hold on, let me just fix this, because that is underneath the radical. Okay, this is 4x plus h, and then plus radical 4x. Okay, so that's better. And remember, this whole thing is multiplied by h, so you have to use your brackets wisely. Okay, let's clean up my numerator. And I'm getting 4x plus 4h minus 4x all over. I have the h outside, and I still have a radical 4x plus h plus radical 4x, close bracket. Okay, remember what I always say? Whatever doesn't have an h attached is going to cancel, and that indeed happened. You can cancel your h with the h down below, and that leaves me with a 4 up top. So let's keep going because we're just about there. Okay, so I have a 4 in the numerator, and I have in the denominator radical 4 times x plus h, and don't distribute these, just leave it be, times radical 4x. Okay, so now I believe I am ready to take the limit. Let me just see if I can get rid of that. I cannot, so I'll have to do this. Okay, there we go. Okay, so taking the limit means you plug in the 0 for your h. So that limit is going to equal, the 4 doesn't change, but look what's happening below. You're going to have this term that will just be radical 4x plus another radical 4x. So that gives me 2 radical 4x's. Okay, now I can clean this up a little bit, can't I? So let's do this first. Let's make that 2 over radical 4x. Now, doesn't that radical 4, can't that come out? So this is 2 radical x. So that's going to equal 1 over radical x. Okay, and that's how we end that one. So you now have information on how to do conjugate pairs, common denominators, cubics, and squares. So you have to go back and practice this, because practice is what you need. So let's go forward, and I'll show you answers from what you practiced the other night. Okay, but let me take this back. Let's do this. Let me finish the notes, and then we'll go to the practice problems. Okay, so here's a whole nother kind of limit. So this limit is as x goes to infinity. So see, it's right here. And here's x goes to negative infinity. So let's think about this, because this is an easy section that people sometimes get wrong. So can you sketch the graph given the limits below? And I say, think horizontal asymptote. So I want you to think horizontal asymptote. This says, as x gets bigger and bigger, the y value goes to 4. So what could that look like? So I'm going to read this as the limit as x approaches infinity of the function is 4. Okay, so here's where 4 is on my y-axis. So what could be a possible function? Well, this could be a possible function, right? As x gets bigger and bigger, here's your x, here's your y. Aren't the y values going to be 4? And that's because you have a horizontal asymptote at the equation y equals 4. Okay, let's do another one. This says the limit as x approaches negative infinity of the function is -1. So where's -1? If you look really closely, you can see that I have -1 here. And as the function approaches negative infinity, it approaches -1. So what if it came down from this direction? Isn't that going to tell that story? Okay, so what about if they give you an equation and they ask you to find that limit? This is what you do. If you do not have an x in the numerator and you only have it in the denominator, plug in the concept of infinity. So 3 over infinity squared plus 3. Okay, that denominator is a huge number. If that was 3 over 100, that's a pretty small segment. If it was 3 over 1,000, that's even smaller. 3 over 1,000,000, even smaller. 3 over 1,000,000,000, even smaller. So that means 3 over infinity squared plus 3. So as the denominator gets so huge, it blows up, and it in effect equals 0. Okay? So if you have only an x in the denominator, this is how you handle it. If you have instead an x in the numerator and the denominator, we have to do an algebraic manipulation. Divide all terms by, I should not say this, so I shouldn't say x, by the highest power of x. Highest power of x. And then take the limit. Okay, so the highest power of x in this situation is just x to the 1. So the limit as x approaches infinity is going to be take every term, divide by x. Okay, when you do this, you don't change anything. You just change the way it looks. Okay, now cancel where appropriate. Okay, these x's cancel. These x's cancel. Okay, so since the x's cancel, you just have an 8 in the top and a 2 in the bottom. Then look at the next term right here. As x goes to infinity, that goes to 0. As x goes to infinity, that goes to 0. What you're left with is 8 over 2. And 8 over 2 is your limit. Okay, that's your limit. 8 over 2, which you can reduce to 4. So, just to recap, when we speak about limits as x goes to infinity or to negative infinity, we are talking about horizontal asymptotes. And we can discover them if we, algebraically, if we plug in, kind of with air quotes, plug in for infinity, and we can see if x is only in the denominator, the large denominator makes the fraction approach 0, and that's the limit. If x is in the numerator and the denominator, we're going to instead divide every term by the highest power of x, and then take the limit after you cancel. Okay, I've got one more for you, so we'll say this is 3. What if this is our problem? The limit as x approaches infinity of 3x squared minus 2x plus 5 over 9x squared minus 7x plus 2. Okay, do not factor and cancel. That's not our goal here. Our goal is to divide, because we have x's in the numerator and the denominator, our goal is to divide every term by the highest power of x, which is x squared. So let's go ahead and do that. So I'm going to write limit again here as x approaches infinity of, 3x squared over x squared minus 2x over x squared. Let me do this. Let me erase this because I'm going to run into it. Let me say this equals, what did we say, 8 over 2, which equals 4. Okay, now I have some more space. Okay, so I have 2x divided by x squared plus 5 divided by x squared all over 9x squared divided by x squared minus 7x divided by x squared plus 2 over x squared. Okay, cancel as appropriate. So these can go, these can go. This can go, the power goes. This can go, the power goes. Okay, so now let's take the limit, which means kind of plug in for infinity. And again, plug in with air quotes. So the limit is going to equal, so I have a 3, I have minus 2 over infinity plus 5 over infinity squared, all over 9 minus 7 over infinity plus 2 over infinity squared. Okay, so what's going to happen, just like the above case, this is going to go to 0. This is going to 0. This is going to 0. And this is going to 0. I am left with 3/9, which can reduce to 1/3, and I am done. So now we've finished the section on limits. 3 types. So, and I'm going to post a document that tells you about the 3 types. Read that. It'll be on Google Classroom as well. And the 3 types are, as x goes to a number, as h goes to 0, that's giving you derivatives. As x goes to infinity, that's giving you asymptotes. As x goes to a number is giving you y values, but sometimes it does not exist. Okay, so let's go to the next page. And this is your little helpful note that when you're doing x as it goes to infinity, what you're finding are horizontal asymptote values. Okay, so let's see what's on the next page. Okay, so what I started doing, I gave you some of these for homework the other night. So I went through this with the class, the odd day class. And so these are my answers. So you should be checking to see if your answers match, and even more importantly, if you have all the notations. So here is 31. You may look over that. Here is 35. You may look over that. Here is 33. You may look over that. Okay, so that ends this video. Make sure you have all these notes written down, and I'm going to give you more work to do. So I am going to post some things. So you're going to read about it on Google Classroom.